Hi guys. Okay, new math lesson, or session at least. We're still on lesson 20 about adding and subtracting fractions, and this is session 4, and I'm on page 429. So this part of the lesson is about decomposing fractions, so that's just what are all the ways that we can add up to get a certain fraction, okay? So let's go through the word problem. It is a very long one, so let's get started. Dan has 5/6 of his reading left to complete for the week. He plans to complete his reading on 2 or more days of the week from Monday to Friday. What are 2 different ways he could plan to complete his reading? Use a fraction to describe the part of his reading he does each day. Okay, so they want us to solve this in 2 different ways. They want 2 different solutions. So let's see, we'll just kind of cut our page in half like that. We'll have one solution up here, one solution up here. So basically, he has 5 days to complete his reading homework, Monday through Friday. So he could do a certain amount of reading each day, or there's multiple different ways. That's why they're asking us to do it 2 different ways, okay? So I'm just going to list out days of the week up top: Monday, Tuesday, Wednesday, Thursday, and Friday, okay? And he has to complete 5/6 of his homework, or he has to do 5/6 more. He's already done 1/6, I'm assuming, right? Because 6/6 would be the whole thing. So we need to find 2 different ways. There's lots of different combinations, okay? But at the end, the total of all of his work has to equal 5/6 because he has that much left, okay? So you could do really lots of different combinations. Maybe he does 1/6 on Monday, 1/6 on Tuesday, 1/6 on Wednesday, 1/6 on Thursday, 1/6 on Friday. So if he does the same amount every single day, 1, 2, 3, 4, 5, that's 5/6. So if you add those all up, it's 5/6, okay? So that's one way he could do it. If he does a 1/6 every single day, by the end of the week, he'll have finished the 5/6, okay? But what's another way? So decomposing fractions is just, what's another way we can break apart 5/6, okay? So maybe he decides to do 2/6 on Monday, and then nothing on Tuesday, and then 2/6 on Wednesday. Maybe he doesn't do anything on Thursday, and then he would have, well, there's 2 plus 2 is 4, so he would have 1/6 more to do on Friday, okay? If you add all that up, 2/6 plus 2/6 plus 1/6 equals 5/6. Okay, so it doesn't matter what days of the week he's doing work on. The point is, there's a lot of different ways we can add things up to get our fraction. There's a lot of different ways we can decompose this fraction. Okay, we could do it with unit fractions, 1/6 the entire time. We could break it apart like this. We could do, maybe another way would be 3/6 on Monday, 2/6 on Tuesday, nothing the rest of the week, and that would still be 5/6, right? So there's a bunch of different ways to make 5/6. Whatever ways you figured out, or if you did the same ones as me, that's fine. 2 stars, and let's answer some questions about it, okay? So on the back of this page, same problem, and then they just show a couple different strategies how to solve it. Okay, so one way that you could break what this is, when you decompose a fraction, you break it into parts, right? So the model showed 2 different ways to decompose 5/6. So you could do 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. That would equal 5/6. Another way is to do 3/6, the light blue section, plus 2/6, and that equals 5/6 total. Okay, so you could use bar models to show it, or you can do equations. So this list shows all the different ways you can add fractions to make 5/6. So see, they all equal 5/6 on this side, but they're all slightly different. So there's 1 plus 1 plus 1 plus 1 plus 1, 1 plus 1 plus 1 plus 2, 1 plus 2 plus 2, 3 plus 1 plus 1, 3 plus 2, 4 plus 1. Okay, and then you can obviously switch them too, right? Because 5, 6 also equals, if you swap those two sides, 1, 6 plus 4, 6. Okay, so it's just showing all the different ways that you can decompose 5 6. Okay, so let's answer some questions about it. Connect it on this side. Okay, number 1, look at the first to model it. So they're talking about these area models. How many equal parts are in each model? How many shaded parts are in the model? So equal parts would be how many equal pieces total. 1, 2, 3, 4, 5, 6. Okay, so in each model, 6 equal parts. And then how many were shaded? It'd be 5, because it's 5, 6, right? Number 2, look at the equations in the second model it. How can you tell if 2 or more fractions add to make 5, 6? Well, if the numerators add up to 5, then the fraction would be 5, 6, because all the denominators are 6, right? So if the numerators add up to 5, or have a sum of 5, then the fraction is 5, 6. Okay. So number 3, what is the greatest amount of his reading that Dan could do in one day? Okay, so he has to do 5 6 total, but he's not going to do all 5 6 on one day. So if he did the most he can do on Monday, what would that amount be? Okay, so he could do 4 6 is the most he could do in one day, because he can't do it all in one. I think it said that in the problem, because he wants to do it on 2 or more. So he could do 4 6 on one day, and that's the greatest amount of his reading. And then on the next day he could do the 1 6, then do the rest of it. But that's our answer for 3. Number 4, what are 2 different ways Dan could do his reading? So on the first day, or on the first way that we figured out, and the first way they did it with this model, that means he could do 1 6 of his reading every day, Monday through Friday. So that's one way, but we have to explain that. So Dan could do 1 6 of his reading each day, Monday through Friday. Okay, so that's one way. He could also do, what was the other way that I had done? 2 6 on Monday, 2 6 on Wednesday, and 1 6 on Friday. Or the way they did it in their second model was 3 6 on one day, 2 6 on another day. Okay, so we can describe either of those. So there's one way, because they're asking us what are 2 different ways. So got little bullet points to separate them. He could do 3 6 on Monday and 2 6 on Tuesday. Okay, because those 2 days combined would be 5 6, the total that he needs to do. Number 5, explain how to find all the different ways to decompose a fraction. So that's like this list, all those equations there. How can we find all of those? Okay, so it's kind of like when we learned about multiples and factors. You just make long, long lists, all the different combinations, okay? So it's not going to be that long of an explanation, but you can copy what I'm going to write. I'm going to say find all the combinations of numbers as numerators, because remember we only add the numerators, that add together to equal the numerator of the sum. That's not numerator. Numerator of the sum. Okay. So like if the fraction in the example was 5/6, how do we find all the different ways we can add to get 5/6? So think of all the numbers in the numerators that you add up to get 5. Like 2 plus 1 plus 1 plus 1, or 3 plus 1 plus 1, or 3 plus 2, or 4 plus 1, or 1 plus 4, or 2 plus 2 plus 1. All the different ways, right? Lots of combinations. So number 6 is reflect. That's for you to write down what strategy you like the most for decomposing a fraction. Do you like making lists of equations? Do you like drawing a model, like an area model, bar model? What's your favorite way? And explain why that's your favorite, and then turn the page. Okay, so once you're ready, we're doing 7 through 9 on this page. So we're using what we just learned about how to decompose a fraction to solve these 3 problems on the back. Okay, number 7. Okay, find 3 ways to decompose 7/8 into a sum of other fractions. Draw a model for each way to show how you know the way is correct. Show your work. Okay, so all we have to do is find 3 different ways to add different fractions together so that they equal 7/8. Okay, so I'm going to have 3 different models because we need 3 different ways. Each model is going to have 8 equal pieces. So this is going to be my strategy number 1. I'm going to separate it. This will be for strategy number 2. I need a model that's, I'm trying to make the exact same size. Rectangle, oh goodness. It's a rough rectangle. Good enough. And number 3. Okay, because we need 3 different ways to decompose 7/8. Okay, so I've got it organized. Here's going to be my first way, second way, third way. I need some different colors, so I've got my choices here. But I need 8 equal pieces to start. Okay, so I'm going to go like that to show eighths. Okay, it's pretty even. Okay, same thing on all 3 models. 8 equal pieces, 8 equal parts. Okay, so I need to find different combinations, different ways I can add to get 7/8. So the total that's going to be colored in my model is going to be 7 for each. So each equation is going to equal 7/8. Okay, so for my first one over here, maybe I have just one purple one, and I'll do 6 red ones. Okay, so that equals 7/8, right? 1, 2, 3, 4, 5, 6, 7. There's 7 total pieces. And I did 1/8, sorry, I said 1/6 almost. 1/8 right there, plus 1, 2, 3, 4, 5, 6. 6/8 or my red ones, and that equals 7/8. Okay, so that's one way I could do it. Another way, maybe I'll do 2 purple and 2 red and 3 green ones. Okay, so that was 2/8 plus 2/8 plus 3/8, because 2 plus 2 equals 4, 4 plus 3 equals 7. 2 plus 2 plus 3 equals 7, my numerator. Okay, so that's another way that you could make 7/8. And what's another way? Whoa. 1, 2 again. Maybe I'll just do one red one and 3 purple ones again, and maybe one pinkish one. Okay, so for my equation, that was 2 purple, so 2/8 plus 1/8 was red, and you don't have to color code these, right? 1, 2, 3 plus 3/8 plus 1/8, because in my numerators, 2 plus 1 plus 3 plus 1, so 2, 3, 4, 5, 6, 7. So all that on the numerators, everything in the top, adds up to 7. Okay, so those are my 3 different ways I can decompose 7/8. And there's lots of other ways. You could do that in a number of different ways. As long as your combinations add up to 7/8, you're good. Okay, so 1, 2, 3 stars. I'm not going to write the solution line because it was really just going to be copying the equation, so there's your equations. Okay, move my pens back over here. All right. Okay, number 8. So complete the equations to show a way to decompose each fraction. So for A, and I'm going to separate this. Okay, there we go, just looking at A. So it's something plus 1/4 plus 3/4 equals 5/4. So I know in the fraction, the denominator is going to be fourths because it's all fourths. But what's my numerator? So here's equals 5. So 3 plus 1 plus something equals 5. I could subtract, I could use mental math, I could use my fingers. So if my numerator's 5, they already got 3 right there, so I'm going to take away 3. There's 1. I'm just left with 1. 1 plus 1 plus 3 equals 5. So 1/4 plus 1/4 plus 3/4 equals 5/4. Okay. B, 3/4 equals 1/4 plus blank. Okay, so I know that's going to be fourths again. So what plus 1 equals 3? That one's a little easier. 2. Okay, 2/4 plus 1/4 equals 3/4. And C, 9/12 equals 3/12 plus 3/12 plus blank. I know my denominator is going to be 12s. So what plus 3 equals 9? 3 plus 3 plus 3 equals 9/12. Okay. All right, and number 9. Draw a diagram to justify your answer to problem 8b. So that's this one here. So we just have to draw a model that shows this. Okay, so it's fourths. So I just need a model with fourths. 4 equal pieces. Okay, and I need to show 1/4 plus 2/4 equals 3/4. So I could do 1/4 plus 2/4. 1, 2, and that equals 3/4. 3 out of the 4 are colored in. So 1/4 plus 2/4 equals 3/4. Done. Okay, next is the practice pages, but if you need to take a break, go to the bathroom, get a drink of water, whatever you need to do before we begin that, go for it, pause the video, and then move on with me. So, in the example problem, they're talking about pi. That's why there's a picture of pi right here. It says Sarah's family has 4/8 of a cherry pie left over. So that's the shaded in half that she has left. Sarah and her sister share the leftover pie. What are 2 different ways Sarah and her sister can each get some of the pie? Okay, so Sarah and her sister each get 2/8 of the pie. So here's Sarah's part, here's her sister's part, the darker red. So that's 2/8 plus 2/8 equals 4/8, which was what was left. So that's the pie they have left, and that's what how they're going to share it. That's how they break it up. Or they could do it like this, where Sarah only gets 1/8 of the pie and her sister gets 3/8 of the pie. Okay, that way does not seem as fair because Sarah only gets 1 piece and her sister gets 3. But it is another way that you could decompose 4/8, right? But this way is way more fair. Okay, number 1. Complete the equations to show how to decompose 3/5 in 2 different ways. So there's 3/5 equals 1/5 plus blank. You know it's going to be fifths. So 1 plus what equals 3? 2/5. Okay, because I look at my numerators. 2 plus 1 equals 3. Okay, and 3/5 equals 1/5 plus blank plus 1/5. Still fifths. 1 plus what plus 1 equals 3. 1 plus 1 plus 1 equals 3. So it should be 2/5 in the first blank, 1/5 in the next blank. Shade the area model below to show the equation in problem 1a. So we want to show that one. Okay, so it's going to equal 3/5. So I need 3 pieces colored in the end, and I need 1/5 plus 2/5. Now I need a different color, or you need to color it in differently so that you're not just shading 3 total, right? Because that doesn't show addition. This shows addition, that I'm adding this purple section plus the red one to equal 3/5. But if you only shade in 3 of them the same way with the same color, then that's just showing 3/5. It's not showing any addition. So you need to color it in differently. So if you're doing it with the same color, that's fine, but shade it in like darker than the other ones or something, kind of like how they do it up here. Darker red, lighter blue, darker blue, okay? So if you shaded 1 in and then 2 in another way or a different color, give yourself a star. And back page. Okay, number 3, select all the equations that show a correct way to represent 7/10. So which of these add up to equal 7/10 correctly? I'm gonna grab my little pad of paper again because it all kind of looks jumbled. So is 1/10 plus 5/10 7/10? No, it is not, because 1 plus 5 is 6, not 7. Can't be A. B, 2/10 plus 5/10 equals 7/10. Yeah, well, the denominators are the same. 2 plus 5 equals 7, so I would say that was a correct way to do it. 1 plus 2 plus 4 equals 7. Well, 1 plus 2 is 3, 3 plus 4 is 7. C looks like a good one. Okay, how about D? 1 plus 4 plus 3. Well, 1 plus 4 is 5. 5 plus 3 is 8. So, nope, that would equal 8/10. And E, whoa, long one, okay. 1 plus 1 plus 1 plus 1 plus 1. Okay, 1, 2, 3, 4, 5, 6, 7. Yep, that equals 7/10. My numerators add up to equal 7. It's tenths all the way across. So it should have just been those 3. B, C, and E. Okay, number 4. I don't know how to say that name. Vijay has 6/6 of a cup of raisins. He wants to put the raisins into 3 snack bags. What are 2 different ways he could put raisins into 3 snack bags? Use a model to show each way. Show your work. Okay, so we need to use a model, so I'm gonna have strategy number 1 over here, strategy number 2 on this side. And since I need to show a model, I need a bar model, and my denominator is 6, so I need 6 equal parts in each model. So I cut it in half, and then each half needs 3. Cut it in half, each half needs 3. Okay, so now I'm set up to show my strategies. He has 6/6 of a cup of raisins, so the whole thing is going to get colored in, but I need to know different ways that he can put it into 3 bags. So it's going to be 3 colors or 3 ways to separate out his raisins, okay? And it doesn't say they have to be equal amounts. Okay, one way can be equal amounts, right? So in one bag he can have 2/6, in another bag he can have 2/6, and in the third bag he can have 2/6. Okay, so 2/6 plus 2, 6 plus 2, 6 equals 6, 6. So that's one way. Each bag can get 2 6. But another way he could do it is maybe the first bag has 3 6. And this one's not going to be an even way. So it's kind of like Sarah and the pie problem. It's not going to be fair. There's not going to be the same amount in each bag. But that's okay. It doesn't say there. There has to be. So 3 6 plus 2 6 plus 1 6 is another way. Because 3 plus 2 is 5, plus 1 more is 6. 6 6. Okay, so you could do it a different way too. Maybe you did 4 6 plus 1 6 plus 1 6. That's fine. That equals 6 6. If you have any other way, that's totally fine too. Draw a model for both ways and give yourself 2 stars. I'm just going to do an arrow for my solution because of laziness. Okay, number 5. Is 7 twelfths plus 1 12th equivalent to 4 twelfths plus 4 twelfths? Explain your answer. Okay, so let's solve both and find out. 7 twelfths plus 1 12th equals blank. So my denominator stays the same. I add the numerators. What is 7 plus 1? 8. Okay, let's solve the other one. 4 twelfths plus 4 twelfths equals blank. Denominator stays the same. Add the numerators. What's 4 plus 4? 8. Are they the same? Are they equivalent? Equivalent means equal. Yes, they are. So, yes, they both have a sum of 8 twelfths. Ta-da! So, yes, they're equivalent, and we explained. And we kind of showed our work too. Okay? All right, that's it for that one. The next lesson, session 5, is the refine day. So this is the one where it's like 8 or 9 problems usually. Yeah, 9. That you should be able to do by yourself. So try those on your own before watching the video. Use the video to correct your answers and count your stars, okay? Adios, see you later.